Hey everyone! So today we're going to solve another Leetcode problem, container with the most water. Without further ado, let's jump to the problem. So the problem is we are given n vertical lines. Each vertical line is from the height 0 to the height I, which I is the index of the vertical line. And each two consecutive vertical lines are separated by 1. So as you can see in the image, this is height 1. Then this is height 8, height 6, height 2, height 5, 4, 8, 3, and 7. And we want to find a container, which means two of these vertical lines with the x-axis form the biggest container that could hold the most water. In this example that we have right now, there is a vertical line 8 and there's a vertical line 7. Their distance between them is 7, and we are bound with the smaller vertical line, which is the height of 7. So 7 times 7 makes it 49. In the second one, they are both at the same size and they are consecutive to each other. So 1 with a distance of 1 creates 1. Let's get to the solution then. So our solution would be a greedy approach, and it's based on two assumptions. First, the further two vertical lines are from each other, they have more water capacity. The second assumption is that we are always bound with the smaller height. If we're decreasing area with the x-axis, we do that from the smaller height. So based on these two, we're going to have 2 pointers starting from both ends. One of them is going to go inwards at each step, and we're going to calculate the new capacity. If it's bigger than the maximum capacity that we have so far, we are going to store the new maximum. And if not, we are going to go one step further with the smaller vertical line. So as always, we're going to implement this with TypeScript. Let's jump to the code and see what we mean by that. So we're going to store the maximum, and for that, we're going to use destructuring of JavaScript. So maximum, we're going to store the left index and the right index, which consecutively would be 0 at the beginning, left would be 0, and the right would be height dot length minus 1. And we will continue until the left is smaller than the right. The maximum is always the math.max of the previous maximum and the new calculation, which let's do it here first. Local max equal math.max, math.mean between height of left and height dot right. This isn't actually the local max, so this is the smaller height, and for this we're going to do the smaller height times so we have a typo here. Right minus left, which would be our x-axis. So smaller height times right minus left would be the capacity, and we calculate that with the maximum to figure out the new maximum. Now, if the height of left is smaller than the height of right, then left is increased, otherwise right is decreased. And last but not least, we return the maximum. Oh, so I see we have a typo at line 3 on length as well. So let's jump to that real quick. and fix this. Okay, so let's run the code first. Okay, it passes all the test cases. Let's just submit it then. And yes, we got an accept. So thanks for watching. As always, your best support would be giving me a thumbs up, writing any feedback. It would really help me, and maybe a subscribe to the channel. And if you're interested in other programming challenges, you could see them here or go through my playlist. Thanks for watching. See you in the next one. Bye.